Algebra 1 students, in this video today we will be taking our first look at what makes an algebraic term and how to simplify these terms. Okay, now let me just tell you right now, you can trust me or not trust me, that's up to you, but being able to count how many terms an algebraic expression has is very important. When we get into factoring, you're going to have to know what a binomial is, a trinomial, a monomial, and those all come down to being able to count terms. Now relax. It is super easy to do, it's not difficult, but you still got to be taught how to do it, so please pay close attention. Your heading for today is Algebraic Terms, Lesson 2.6, and be sure to include today's date. So please write all of that down. Algebraic Terms, Lesson 2.6, and be sure to include today's date. I want to start off by showing you what a term is. Now I don't want you to take notes on what I'm about ready to show you, okay? I just want you to sit back, watch, and listen. Alright? So here we go. Don't write this down, just watch, okay? I'm just making this up as I go. Now, we know by now in algebra, whenever numbers and letters are directly side by side, it means to do what? Multiply. We know that, okay? So whenever a really big, or small for that matter, I should not have said really big, anytime an expression, whether big or small, is all multiplying. Now remember, let's do it. Don't write this down. Just listen. Trust me, okay? You're going to take notes on this in a second. For now, just sit back and watch. Whenever an entire expression is all multiplying, that's one term. One term, one term, one term. Got it? I wrote one here that was really long because a lot of you might have thought, well, that's got to be a lot of terms. Maybe every letter's a term, so I've got 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7, 8, 9. This is 9 terms, but that's incorrect. This entire expression right here is one term because everything is multiplying. Now, I want you to just sit back and watch, okay? Just keep watching. Now, let's say I got rid of this right here, and let's say I put a plus sign in there. Well, now I have two terms. All of these are multiplying. Then there's a positive sign, and all of these are multiplying. You see what I'm saying? So now I have two terms. Positives and negatives are what split an expression up into terms. Positives and negatives. That's really easy. Again, I'd like you to just watch and not write anything down. Just watch, okay? Let's see, right here I put a negative sign. Alright. Okay, well let's see. I start here and I go along. Oh, there's a negative sign, so there's one term. Okay, all of these are multiplying. Oh, there's a positive sign. So I have three terms. It really doesn't matter what this leading sign here is. That's not important. But as you go through an algebra expression, positives and negatives divide an expression up into terms. So this expression here has how many terms? 3. Do you see it? Okay. Let me do one more and then we're finished, okay? Let's say right here I put a negative sign. Alright? Let's count the terms. Here's a term. Then I see a negative sign. Here's a term. Then I see a positive sign. Here's a term. Then I see a negative sign. Here's the term. Are you listening? How many letters I have doesn't matter at all. What my exponents are doesn't matter at all. How long the expression is doesn't matter at all. When it comes to counting terms, positives and negatives divide an expression up into terms. So this expression here has how many terms? Got it? Now, I do want you to write this down, okay? Positives and negatives divide an expression into terms. Don't ever forget this. Please write down this first sentence right here in your notes. Don't ever forget this. Positives and negatives divide an algebraic expression into expression and count the terms. Let's quickly do this, okay? Copy this first problem in your notes. I would like you to tell me how many terms are in this expression. Well, I see a term here, then a negative sign, then a term here. So this expression has two terms. And by the way, the signs do matter. This term here is negative. This term here is negative. That does matter. Okay, let's try another one. How many terms are in this expression? Well, I've got a term here, then I see a positive sign, then a term here, then a negative sign, then a term here. This is not two terms right here. Okay, remember the only thing that divides an expression up into terms are positives and negatives. So this expression here has how many terms? 3. Do you understand? This term here is positive, this term here is positive, this term here is negative. Okay, let's take a look at another one. How many terms does this expression have? Well, I don't care how big this is, there are no positives or negatives, so there's one term. Here's my next term, here's my next term, and here's my next term. So I have a total of 4 terms. Got it? This term here is positive, this term here is negative, this term here is positive, and this term here is negative. Okay? It's very important because I'm going to use the phrase a lot this year. Like using steps to solve certain equations, I will say like move this term here, move that term there. And you have to know what a term is, okay? Alright. Now that we've established what a term is, let's take a look at simplifying algebra expressions. Simplifying algebra expressions. So here we go. Please copy down this first problem. Don't worry about the rest of them. Copy down this first problem. Now, we call this expression here, it's a binomial. We'll get to that later. There's 2 terms. Here's one term, here's another term. But notice these 2 terms are what we call like terms. I would definitely write that in your notes. Let's talk about that for a second, okay? These 2 terms are called like terms. They are like terms because they both have an x. We call these x terms. Got it? X terms. Now, if I had x squared right here, then these 2 terms would not be like terms. Okay? If I had a y thrown in right here, then these 2 terms would not be like terms. This is an x term, this is an xy term. This is an x term. This is an x squared term. Okay? Understand? The variables have to be identical. I don't care about the numbers, the coefficients. The coefficients do not matter. But in order for us to have like terms, the variables must be identical and their exponents too. Okay? Like, look at this example down here for a second. This term right here, x, is not a like term with this term here because one's x and one's x squared. Okay? Alright. So let's combine these like terms. Are you ready? Here we go. Anytime you have like terms, you can combine them. I don't like the words adding and subtracting. I like the word combine, okay? So I have a positive 8 and a positive 3. In other words, you have $8 in your wallet. You have 3 more dollars given to you. You now have 11. There we go, 11x. It is not 11x squared because you have 2 x's, so you put x squared. No, that is incorrect, okay? It's 11x. The variables stay the same. You're just combining the coefficients. For example, don't write this down, just watch. If I had negative 2xy squared, positive 6xy squared, these are like terms because I have xy squared. You would leave the x and the y squared alone, and you would just simply combine the coefficients. You owe me $2. You have 6 in your wallet. You pay off your debt, and you're left with positive 4. That is how that would work. So the variables do not change when you're combining like terms. So 8x plus 3x is 11x. Pretty simple. Alright, let's try another one. You could that's up to you, but make sure you check your answer if you work ahead. Now, let's simplify this expression if at all possible. Sometimes you can, sometimes you can't. I have an x squared term here. Do you see any other x squared terms up here? Yep, right here. So I'm going to combine these two terms. I'm going to put those two terms together. I'm going to put my x squared right here. I have a positive 5 and a negative. Now there's no number here. When there's no number in front of your variables, you are allowed to put a 1 there for the coefficient. So that negative really means negative 1 squared. If this would have been a positive sign, then it really would be a positive 1x squared. Okay? So if a term has no coefficient, you can put a 1 in front of it. That's fine. So a positive 5 and a negative 1, you have $5. You pay off a $1 debt, and you're left with 4x squared. So I'm going to cross these off. I'm done with those. Now you're left with a positive 2. By the way, a positive 2 is called a constant term. If you want to make note of that, it is a constant term. We call it that because there's no variable with it. It's just a number. Down here, here's a constant term. Here's a constant term. They have no variables with them, okay? Do you see any other constant terms up here to combine with this positive 2? Not at all. So just bring it down. Mr. Earhart, how do we know that we're finished? We know that we're finished because we don't have like terms. If there are no like terms, then there's no combining that you can do, okay? This is an x squared term. This is a constant term. They are not like terms, so you cannot combine them. So we're finished. That's our answer. Let's try another one here. You can work ahead or watch me. Okay, here we go. I have an x squared term here. Do you see any other x squared terms? I see one here. And that's it. This is an x cubed term, so that's it. So I have a positive 4 and a positive 3. Let's combine those. Positive 4, positive 3 is a positive 7, and then bring down your x squared. Put a check mark here, put a check mark here. Let's go to the next term, an x term. Do you see any other x terms anywhere? Yeah, I see one here. And that's it. This is not one, that's not one, that's x squared, x cubed, so x term, x term. I have a positive 1 and a negative 7. Positive 1, negative 7, let's combine those, okay? You have $1 in your wallet, but you owe me 7, so you pay off part of your debt, and you still owe me 6, so it's negative 6, then bring down your x. Now let's look at this term. It's a constant term. Do you see any other constant terms up here? Right here. A negative 5 and a negative 11. Let's combine those. You owe me 5, you owe me 11 more, so now you owe me 16, negative 16. Alright, let's check that off. And then lastly, I have an x cubed term. So positive 8x cubed. Bring that down and we're finished. Now, I know that I'm finished because there are no like terms anywhere for me to combine. Nowhere. None. That's an x squared term, that's an x term, that's a constant term, that's an x cubed term. There are no like terms anywhere for me to solve, for me to combine. Alright, let's move on. So what we just did there is we looked at combining like terms. So we were simplifying algebra expressions by combining like terms. Pretty simple, it's not too difficult. Alright, now let's throw in some multiplication, okay? Let's throw in some multiplication and let's see what happens. Please take some really good notes, okay? Let's start off with this one here. Now, here in this problem, I look inside the parentheses. Inside the parentheses, I have an x term and a constant term, correct? X term and a constant term. They are not like terms, so I cannot put those together. For example, if I would have had this, if the parentheses would have said x plus 5x, then go ahead, they're like terms, are they not? X term, x term. You combine those, there's a 1 here, and you would get a 6x. Then you could multiply and you'd be finished, okay? But in this case, these two terms right here are not like terms. times this 2 right here is a constant term, and this x is an x term. You can't multiply it. Well, yes, you can. What I said is you cannot combine unlike terms, okay? You can definitely multiply unlike terms. That is totally fine. So I'm going to take this 2 and multiply it through, alright? 2 times x is 2x. 2 times 5 is positive times a positive, positive 10, and we're finished. Look at that. Positive times a positive is positive 2x. Positive times a positive is positive 10. Now you know you're finished because look at this answer. You have no like terms anywhere. Nowhere. Okay? So you're finished. There's nothing you can do. You know what? If there would have been like terms here, pretend there would have been an x here, then you could go ahead and combine those and put 12x, okay? You always want to combine like terms as far as you can, alright? Let's take a look at this next problem here. Alright, now, we don't have like terms here, so we're not going to combine those. However, we can take our x and we can multiply it through, okay? X times x, now think about it, x times x, look, if I had 2 times 2 times 2 times 2, that's the same thing as 2 to the what power? 4th, right? I have 4 2's. So x times x is x times x, which is the same thing as x squared, alright? Positive times a positive is positive. Now a positive times a negative is a negative. X times 4 is simply 4x. Now you know that you're finished there with that problem because there are no like terms. Your first term is an x squared term, your second term is an x term. They are not like terms. We are finished. Alright, let's take a look at another problem here. Alright, there are no like terms that I can simplify inside this parentheses. And notice this negative 8 is written right next. We have a parentheses next to a parentheses, so this parentheses here is multiplying itself times this parentheses here. Now I want to be very clear about something. You better listen to me, students. If I had this for the problem, please look at this. If I had this, then the negative 8 would not be multiplying times this parentheses would not be. That would just be 1 plus x, then minus 8, or 1 positive x, then negative 8. But because I have this, now we have multiplication. Please understand that. Now sometimes students get confused when the number's at the end like this, so I'm going to write at the beginning. You can do that, correct? You can switch multiplication around. 2 times 4 is the same thing as 4 times 2. That doesn't matter. Alright? So here we go. Now be careful with your signs. Notice I'm multiplying a negative. So a negative 8 times a positive 1 would give me a negative 8. A negative times a positive gives me a negative 8 times 2x is 16x. Let's go over this again. A negative times a positive is negative. 8 times 1 is 8. A negative times a positive is negative. 8 times 2x is 16x. We know we're finished because we have no like terms right here. None. This is a constant term. This is an x term. They are unlike terms. Let's try another one. Okay, now we have a negative y right next to the parentheses, so we know they're multiplying. There are no like terms here that we can combine. So let's go ahead and take our negative y and let's multiply that through. Alright, so here we go. I have a negative times a positive is negative. Y times 2y. Now think about that. Y times 2y would be 2y, which would simply be 2y squared. Got it? Y times 2y is 2y, which is 2y squared. Negative times a negative squared term. This is a y cubed term. They are unlike terms, so I am finished. Okay? You've got to understand this stuff, guys. It's very important that you can simplify algebra expressions. Let's finish this video by putting together what we have learned into some big problems. Okay? Some big problems. And here we go. Alright, let's start off with this one. You can work ahead or watch me. I see no like terms I can combine. Oh yes, I do, Mr. Earhart. There's a negative a and a negative a. True. But we have parentheses here, so we've got to start here and get rid of our parentheses first and then combine our like terms last. So we first must get rid of this parentheses. We're going to do that by taking this 4 and multiplying it through. Okay? So positive times a positive is positive. 4 times 2 is 8. Positive times a negative is negative. 4 times a is 4a. Do not multiply the 4 times this a. It is not inside the parentheses. Do not do that, okay? Just bring it down. Now I see some like terms. I have an a term and an a term. A negative 4 and a negative 1. Let's combine those. Let's first of all bring down our positive 8. You owe me $4. You owe me one more dollar. Now you owe me $5. 5a. There we go. That's my answer. Pretty cool. I know that I'm finished because I do not have like terms. There's nothing else I can do. Alright. Moving on. Okay, now you're welcome to leave the negative x here and multiply it through. I have no problem with that, okay? But sometimes students understand it easier if we pick it up and move it toward the front, okay? Either way, I have a group here times a group here, alright? So I'm going to put the negative x out front. Sometimes that helps students see this a little better until they get more used to it. And then put your positive x squared. So I simply swapped places with these two parentheses, alright? And here we go. Now watch your signs, be careful. Negative times a positive is negative. X times 5 is 5x. Negative times a negative is positive. X times 2x would be 2xx, which is 2x squared. Then bring down your positive x squared. I see some like terms, don't you? Sure you do. Here's an x squared term. Here's an x squared term. Positive 2, positive 1. Let's combine those. Positive 2, positive 1 is a positive 3x squared. Bring down your negative 5x and we're finished. Now, one thing I forgot to say, and I apologize for that, is whenever you have your answer like this, it does, you can write them in whatever order you want. If you want to put the 3x squared first, that's fine, as long as you keep the positive sign with it. If you want to write this second, that's fine, as long as you keep the negative sign with it, okay? So this is the same as this. Now later, we're going to learn how to write these in something called standard form. But right now, I'm not really worried about that. Okay, we'll get into that later, okay? So either one of these two answers would be acceptable for now, okay? Alright, let's try 2 more, and we're finished. 2 more, and we're finished. Okay, here we go. Pretty standard problem. We have a negative 4 being multiplied times this parentheses here. Let's take our negative 4 and multiply it through. Negative times a positive is negative. 4 times y is 4y. Negative times a positive is negative. 4 times 2 is 8. And then do not take the negative 4 times the negative 6y. The negative 6y is not in the parentheses. Just bring down your negative 6y. Now we're looking for like terms. I have a y term and a y term, negative 4, negative 6. You owe me $4. You owe me 6 more, so now you owe me 10. Bring down your negative 8, and we're finished. If you wanted to, you could write the negative 8 first and the negative 10y second. That does not matter for now. There we go. Okay, 1 more and we're finished. Okay, let's simplify this expression now. Here's a negative x cubed. It's all by itself out here. It's not being multiplied times anything. We can go ahead and just bring that down if we want to. Now, I've got a positive 2x right next to a parenthesis. This positive 2x is going to be multiplied through the parentheses, okay? So here we go. Positive times a positive is positive. 2x times x would be 2x, that's 2x squared. And then a positive times a negative is negative. 2x times x squared, that would be 2x, x squared, which is really 2x, x, which is 2x cubed. Okay? Now I do see some like terms. Here's an x cubed term, here's an x cubed term, negative 1 and a negative 2. You owe me $1, you owe me $2 more, so now you owe me 3, so negative 3x cubed. And then bring down your positive 2x squared. And look at that. We're finished. We know we're done because we have no like terms to combine. This is an x cubed term. This is an x squared term. So they're unlike as far as we can go. If you want to write the positive 2x squared first and the negative 3x cubed second, that is totally fine. You can put a plus sign here if you want to, a positive sign, but you don't have to. That's up to you. And there we go. Okay? Guys, I really hope this video has been a help to you. If you have any questions, don't hesitate to call or email.